We're now going to take a look at a very powerful collection data type in Python called a dictionary. Now, unlike the data type string and the data type list, which are sequential, a dictionary is referred to as an unordered collection. Now, what that means is that the items in a dictionary are not stored in any underlying order, but rather they are accessed through a different mechanism than, say, position. If we wanted to draw a picture of a dictionary, we might think of a dictionary as a collection object. So we'll draw the collection as a big circle, where the items of the collection are simply inside the object, and each item consists of one entry in the dictionary. Each item is going to be what's called an association, and it's an association between what we refer to as a key and what we refer to as a value. And so we say that each item of the dictionary is a key-value pair, where part of the pair is the key and the other part of the pair is the associated value, the value that's associated with that key. Now, these keys and values, the powerful thing about dictionaries is that you can choose anything you wish in terms of representing associations. The only rule is that the key for the item has to be a piece of data that is immutable. So, for example, integers or strings, those types of things can be used for keys. The value part of the association can be absolutely any Python data object whatsoever. So, for example, let's assume that we would like to create a collection of data items representing associations related to information about temperatures in the town of Decorah, Iowa. So if we go out and look at the weather website, we find out that in the month of January, the average temperature here is 15 degrees. In the month of February, it's 21 degrees. And in the month of March, it is 34 degrees. So what we'd like to do is think about storing this information in a collection, but if we tried to store it in a list or tried to store it in a string, it would be difficult for us to think about how do we make the connection between January is 15 and February is 21 and March is 34. But a dictionary where we can have key and value associations is the perfect kind of data structure to store this kind of information. So what we'll do is we'll create items in our dictionary where the key is the month and the value is the average temperature. So let's go over and take a look at how we would do this in Python. When we create a dictionary in Python, we do like we typically do, and that is we provide a name. And so let's call this object temps. Temps will be a reference to, and now we're going to create a new dictionary. Strings, remember, are created with quotes. Lists are created using square brackets. Dictionaries are created using curly braces. And so the way that we create a dictionary is by providing a number of key-value pairs. And we separate the key and the value by a colon. So our temperature information would look something like this. In the month of January, colon, the temperature is 15 degrees, comma, the next entry, in the month of February, the temperature is 21. And in the month of March, the temperature is 34. When we close off the dictionary entries and hit return, what we've just done is to create a reference, a named reference called temps, which is referring to this collection of key value pairs. So our dictionary now consists of 3 items. The first is the data value 15 associated to the key January. The second is the data item 21 associated to the key February. And the third is the data value 34 associated with the key March. The important thing to realize, however, is that these entries do not have any inherent order. And you might think to yourself, well, they look like they are maintaining the order that we put them in. But we'll see later that that's not exactly true. Now, it turns out that like every other piece of Python data, there are some basic operations that we can perform. So for example, we can use the length function. Similar to lists and strings, the length function working on a dictionary returns the number of items in that dictionary. So notice that this is the number of key value pairs. There are 3 key value pairs present in this dictionary. Another thing that we can do is ask whether a particular key is in a dictionary. So we could ask the question, is March a key in the temps dictionary? And that's true. But if we ask the question, is June a key in the temps dictionary, that would return false because we don't have an association where June is the key. Notice, however, that if we ask, is 15 in the temps dictionary, we also get false. And the reason for that is because even though 15 appears in the dictionary, it's not a key. 15 is a piece of data that's associated to the key January. Remember that each item is a key associated with a piece of data. And so the in operator is asking whether something is a key in the dictionary. Likewise, we can ask the similar question, not in, and we get the expected Boolean value.